All right, so finally we're on the last lesson of the day. So we're going to look at distance and time graphs. So distance time graphs are used to show how far something traveled in a certain amount of time. So a straight diagonal. Just remember that my first language is French, so sometimes I can't say all of the words. So line shows an object is moving at a constant speed, so at the same pace. A horizontal line shows an object is not moving at all. And the steeper the line, the faster the object is moving. The direction of the line shows movement away from positive or towards an object. So if we look here at example 1, so we've got different graphs and different statements. So we have to match each description to one of the graphs below. So after the party, Tom walked slowly all the way home. So this shows quite a bit of change. This shows somebody walking and then stopping and then maybe going back or walking slowly. Same with that, so it changes, whereas this one is constant. So it says that he just walked slowly all the way home. So he walked slowly until he got home. So I would say that this one, so he was at the party here. Okay, so he's at the party. Walked slowly. And got home. So this is home. Okay, so this would be A. Now if we read B, so Tom went out for a walk with some friends. He suddenly realized he had left his wallet behind. He ran home to get it, and then he ran to catch up with the others. So this would be home. So he's walking at a steady pace, realizes his wallet is gone or he doesn't have it. Runs all the way back home. So this is back home. And then he runs to catch up. So this would be B. C, Tom ran from home to the bus stop and waited. He realized that he had missed the bus, so he walked home. So here would be home. So I'm just gonna put H for home. Waited for the bus. And he went back home. Okay, so this would be C. And then D, Tom skateboarded from his house, so home. He gradually built up speed. He slowed down to avoid some rough ground, and then he sped up again. So this would be D. Okay, so I'm going to clear that, and we're going to look at how to calculate speed from a distance time graph. Okay, so our formula for the speed is distance divided by time. So if we look at A here, so we have line A, so we have this to here is our A value. Okay, so this is A. That's supposed to be a scribble. So what we're gonna do is we're gonna do the distance which is 20, right? So we have distance right here is 20. Go down the line. Okay, so distance would be 20. And then our time is 6. So we do 20 divided by 6, and that would give us 3.333 meters per second. Okay. Next, we're going to look at line B. Okay, so we have distance. So here we have to go from this point to this point. So it went 20 meters. It's not 40 because we're looking from this point to this point. So our distance changes 20. Okay, and then our time has to do with here. So again, we want to do the distance from there to there. So that is 2. So line B is 10 meters per second. Okay, and then finally we've got C here. So he didn't go anywhere. He stopped, so it's 0 over, and again, we want the time from here to there, from that point to this point. And that is 2, but 0 divided by 2 is 0, so meters per second. Okay, so distance over time. And this should say seconds. So at 7 seconds, how far did Johnny make it to? Okay, so after 7 seconds, so we're gonna look here, 7 goes up to here, okay? So it would be 30 meters after 7 seconds, okay? And how long did it take John to get to 18 meters? So we're gonna look here at about 18, okay, until we hit the line, and the line's at about 5 seconds. Okay. And that's it for that one. So I'm going to clear this. So for your independent practice questions, you're going to look at the graph and answer the questions. So remember that distance or speed equals distance over time. Okay, so you're going to need to do that as well. So good luck, and I will talk to you guys this afternoon.